Okay, so in the previous video, I explained the two ways we can generate sequence in series. Yeah, that proportional sequence. That is by adding and subtracting, and then two by multiplication or division. Yes, of a constant term by the preceding number or the preceding term. Yes, okay. Yes, and then I also talk about the fact that we have terms in what sequence. So if today the first time you're visiting my channel, make sure you go visit the previous video, then you read before you come to this one. Yes. Now let's move on. I'm going to talk about the arithmetic progression. So first, arithmetic progression. Progression or linear sequence. Now this one is what we call the AP, where the AP represents the arithmetic progression. Now I talk about the fact that when you go to generate this one, this arithmetic progression or the AP, you have to generate them by adding or subtracting. Now example, the previous example. Now if the first term is 5, second term is 10, 15, 20, 25, we can generate other terms. Now in the previous video, I said this one is the first term, that is T1. Now let's see how we can generate it, then we generate a formula for it. Now, let's see how we can talk about it. Now before, how can I get the next number, that is 30? This is the first term. Now out of this first term, from here to here they had 10. So I can say that 5 was added to the 5 to get the 10. So I'm using the word a phase constant. I am using the constant 5. The constant 5. The constant number 5. So this 5 was added to this one to get the 10. So plus 5. Now from here to here 5 was also added. From here to here 5 was also added. From here to here 5 was also added. So it means that before I will get the next one, I need to add 5, which will give us what? 30. I need to add another 5 to get the next number, which is what? 30. You get it? Now, what is the name given to the number 5? Now, let me look at this one is by addition. Let me look at how we can generate another one without addition. Now, subtraction. Let me apply subtraction. Let me apply subtraction. Now, with the subtraction, I can say that how can I get a constant 5? I can say that when I subtract the 10 from 5, when I subtract the 5 from 10, it is going to give me 5, right? Now when I subtract the 5 from the 10, I'm going to get what? I'm going to get the same 5. When I subtract the 15 from the 10, I'm going to get what? 5. When I subtract the 25, the 10 from 25, so I mean 25 minus 20. When I subtract the 20 from the 25, I'm going to get what? The same 5. When I subtract the 25 from 30, I'm going to get what? The same 5. So it means that these numbers are having a difference, a constant difference of what? 5, 5, 5, 5, 5, 5. So therefore, we can differentiate or we can define AP in a different way. So I can define AP arithmetic progression as sequence of numbers that has a common difference. Now the common difference, I use G to represent the common difference or constant difference. Constant what? Number. Or a constant difference. Now when I talk about constant G, it means that this particular number that is common, it is common to all numbers, it's the same. it is 5 throughout, and since it's 5 throughout, we call it what, a constant number, you understand? Yes. So in which the difference is constant, or sequence of numbers in which the difference is constant. You understand? The difference is constant. So the constant difference, we are using D to represent a constant difference. So with this one, the difference is 5, 5, 5, 5, 5, 5, 5, 5, 5. Yes. Now, so when we are generating sequence of numbers, what we need is the first number, that's the first term. So with the first term, and then we also need the common difference. If you're able to get a common difference, you can generate all of them. So since the common difference or the constant difference is D, which means the G is the 5, because we added 5 to the 5 to get a 10, we added 5 to the 10 to get a 15. So the D becomes the constant difference. The D becomes a constant difference. So let's see how we can generate some formulas related to this. Let's see how we can generate the formula related to this. Now let's come to T1. Now we have formulas related to this. I'll come to generate the formula, so pay attention carefully. Now T1, the T1 is 5. The T1 is the first and it is 5. Now what is the T2? Now I am going to use A to represent the first term. So T1 is the same as A, which is the same as 5. So look at, follow me closely. Now T2, what is T2? The T2 is 10. How did we get a 10? We added 5 to this one, the 5. So it was 5 plus 5, which is 10. Now, what is the meaning of the 5? The 5 here is A. Follow me closely. And then what is the meaning of this particular 5? This particular 5 is the constant difference, because I added this 5 to this 5 to get a 10. You understand? So it's the constant difference. So I am using the constant to D to represent the letter D. So which means that 5 plus 5 is same as 5 plus D, where the 5 is the first term, that is 5, and then this 5 is the constant difference, because this one is generated by addition of 5. You get it? So I'm using D to represent a constant difference. That is what? 5. Now let's move on to the next one. So don't forget that T1 is the same as A. The T2 is now A plus D, where D is 5. Don't forget that D is equal to 5 in the question. Now let's come to T3. Follow this one closely because it's a formula. Now the T3 is this one. Don't forget this one, the first term, second term, third term. T3 is 15. How did we get the 15? How did we get the 15? We added 5 to the 10. So it was 10 plus what? Plus 5. It was 10 plus 5. Right? Yes. Now look at this carefully. What is 10? 10 is the T2. 10 is the T2. And in the question, T2 is A plus D. Don't forget, the 10 here is the T2. And T2 is what? A plus D. Now plus 5. What is 5? 5 is the constant. So plus 5. 5 is D. So which means this one will be the same as what? A plus D plus D will give us what? It will give us 2D. D plus D will give us 2D. Now we are generating formulas. Now after generating the formulas, I will just manipulate the formulas, then we see what we can do. Now let's move on to this. So this one is the first formula, the first term. This one is the second term. This one is the formula for the third term. The third term here has the formula A plus 2D. Keep it in your head. Now the T2 has a formula A plus D, because before we can get the T2, I need to add 5 plus the D, which is 5. That's the common difference. Don't forget the D is common difference. we get the common difference, it was 10 minus 5. It was 15 minus, the difference was 10 minus 5, or 15 minus 10. I will talk about that. And that one is given as 5, 5, 5, 5, 5, 5, 5, 5. Follow me closely. Now let's come to T4. Let's come to T4. What is T4? T1, T2, T1, T2, T3, now T4. T4 is 20. How did they get a 20? It was T3 plus what? It was the 15 plus 5. It was 15 plus 5. So the T4 was, how did we get this one? We added 5 to the 15. So it was 15 plus 5. What is the meaning of the 15? The 15 is the T3. Don't forget, the 15 is the T3. T3. You got it? So it was the T3 plus 5. Now, the T3 now has a formula A plus 2D. So it has a formula A plus what? 2D. That is for the T3. Plus 5. What is 5? 5 is the G. So 5 is the common difference. That is D. So when you add, you're going to get what? You're going to get A plus what? 3D. Look at the pattern very well. Now this one is T4. We are getting what? A plus what? 3D. This one is T3. We are getting what? A plus 2D. Which means that we have A. This one is T1. We are getting A. This one is T2. We are getting A plus D. This one is T3. We are getting A plus 2D. This one is T4. We are getting A plus 3D. Now let's do the last one, T5. So T5 is here, this one, T5. T5 is 25. How did we get a 25? We added 5 to 20. And what is 20? 20 is T4. So we see 20 plus 5 to get 25. So this one is the 20 plus what? 5. Now what is 20? 20 is the T4. T4. So T4 plus 5. Now what is T4? T4 is A plus 3D. A plus 3D. T4 is A plus the 5. What is 5? 5 is what? Is the common difference or the constant difference, that is T. So when we add this, we're going to get what? We're going to get A plus 4D. Now at this point, we can generate the rest without thinking. Now let's see how we can generate the rest. Now let me talk about T6. How are we going to get T6? Now the T5, let's look at the pattern. The T1 is A, the T2 is A plus D, the T3 is what? A plus 2D. So look at it, since here is 3, this place is D. Here is 2, here is 1, which means you reduce by 1. Now this one is T4, here is what? 3. This one is T5, here is what? 4. So which means T6, here is supposed to be 5 in that order. So we're going to have A plus 5D. You see? Now T6, a T7, then we need to reduce this one by 1, which is A plus what? 6D. Then T8 will give us what? A plus 7 what? The D. You reduce this one by 1. So we can write this one plain T100. What will be T100? You reduce this one by 1. So to be A plus what? 99D. What is T100? T100 is the same as the 100th term. That's the number at the 100th position. The 100th position. Now at this point, let's see how we can deduce the nth term. Now what about the nth term? The nth term means that the last number, if we don't know the n, we don't know the n is not 5, the n is not 10, the n is not 100, it's not 200. How are you going to generate this one? Look at something here. Can you see that? Starting from here, let me make this one clear. I want to write this one in terms of the 3. Can you see that here was 3, but the 3 is now 2, meaning the 3 was reduced by 1. So this one can be written as what? A plus 2 minus 1D. A plus what? 3 minus 1d. What is the meaning of the 3? The 3 is the same as the particular term, so you use this one by 1. Now let's come to this one. So this one is a plus, it is 4 term, but it is 3d. So I can say that this 4 was reduced by 1 to get a 3. So the same as 4 minus 1d. So 4 minus 1 will give us 3. Right? I'm generating a formula. Now what will be the T5, which means you subtract 1 from the 5 to get what? The 4. So here will be a plus what? 5 minus 1 what? 5 minus 1d. Now what will be here? You reduce the 6 by 1, so it is a plus what? 6 minus 1 what? D. So that 6 minus 1 will give us 5, so the same as 5d. Now what about here? The same as what? A plus what? So before I will get a 6, I can subtract the 1 from the start, so 7 minus 1 what? D. Now with this one, we are just checking the pattern, then we generate a formula for it. Now what about this one? This one is 8, so which means to be a plus what? 8 minus 1 what? D. So 8 minus 1 will give us 7, the same thing. Now what about 100? 100 and then here is 99, meaning we subtracted 1 from the 100. So which means that it is a plus what? 100 minus 1 what? D. Then what will be Tn? What will be Tn? What will be Tn? Then the Tn will give us what? The same a plus. Now since we subtract, we reduce the particular position by 1, it means that I need to also reduce this one by 1. D. So this one becomes the end term of the sequence. This one becomes the end term of the sequence. So this one is by deduction. So let's see. So what I'm saying is that, what I'm saying here is that now what I'm saying here is that the first term is equal to a, the second term is a plus d, the third term is a plus 2d, the fourth term is a plus what? 3d, the fifth term is a plus what? You reduce it by 1, 4d, and this one is supposed to be at the fingertips. Now up to the nth term, the nth term is a plus n minus 1d. A minus 1d. Now, let's look at something. Now, when, let me define it. Now, when A is the first term, A is the first term, D, okay, let me start. N is the nth term. So n can be 4, it can be 5, it can be 6, it can be any other number. Now, or let me say, is the number of n term. Number of n term. Now, and then this one will give us the nth term. Don't forget. Now let me come to the D. The D is the constant difference or the common difference. The D is the common difference or the constant difference. Now let's break this one down. Don't forget that we talk about the D. If you have 5, 10, 15, 20, the D is the difference between the 10. So 10 minus 5, or the D is 15 minus 10. The D is the difference, 20 minus what? 15. So this one will give us 5, this one will give us 5, this one will give us 5. Now since it is given us 5, 5, 5, 5, 5, we call this one the arithmetic progression. or the linear sequence because it has a common difference or a constant difference. Yes, a common difference or a constant what? Difference. So let me say a common or constant. A constant difference. Common or constant difference. Now, let's see. Now, if I want to use the terms to represent, I will see that here is T1, T2, T3, T4. So which means common difference I can say T2 minus T1 or T3 minus T2, just like this one, or T4 minus T3. You get it? Now this one we can generate formula for the common difference. So if I want to generate the formula for the common difference, look at this. T4 minus T3. So the common difference can also be written in terms of n. So when here is 4, you reduce the 4 by 1 to get a 3, right? Yes. So this T3 is the same as 4 minus 1. This one is the same as 3 minus 1. This one is the same as 2 minus 1. So which means Tn minus what? Tn minus 1. So you need to give this one. Tn minus T sub n minus 1. So this one will give us the common difference. Yes. Yes. So this AP is as simple as that. It's as simple as that. Now in the next video, I'm going to solve questions on the AP, arithmetic progression, using this particular formulas. So follow me closely. See you in the next video.